Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at the StringBuilder object. We have looked at the StringBuilder object before, but we're going to revisit it today. The StringBuilder object gives you a very easy and a very fast way of accumulating data in a string variable. In many applications, you may find the need to build up a report incrementally, adding data records to a string variable to provide a report to be emailed, saved or sent to a user. You can quite easily use an existing string variable and just keep appending to it. But we're going to compare that approach with using the StringBuilder object to see which is more performant. So what we'll do in our code is we'll create a small function whose job it is to accumulate data within a string variable. We'll call that function addToString. Within this function, we're going to run through 50 iterations of adding data to a string variable. So we're going to need a couple of variables, one to keep track of our iterations and one for a string to hold the data we're going to build up. And we're going to use a for next loop to run through 50 iterations of this. We're going to take the data variable and we're going to add a formatted string to it, the formatted string being our loop counter. So this string will contain the numbers between 1 and 50. So that we can easily fit these on the screen, I'm going to put a line break in after each 10 numbers. We can do this quite easily by using the mod command. The mod command returns the remainder of the division of one number by another. So we're dividing what's in the long R variable by 10. If the remainder from that division is 0, it means we've reached a 10 boundary. And we can add a carriage return line feed using the $CRLF to the end of our string. And at the end of our function, we're just going to send that string out to our log. Let's try running that now and see what it looks like. And there are our 50 numbers. We have 5 rows with 10 numbers in each row. So that works reasonably well. As we're going to be looking to see how performant this function is, we'll need to work out how long it takes to actually run. You could do this by working out the number of seconds, but as you've seen, it does run very fast. So we're going to use the ticks command. This is a command inbuilt to PowerBasic that allows you to count the number of CPU cycles that something takes to run. So we'll need to create a new variable, in this case a quad variable, which can store some very large numbers indeed. So having declared our quad variable, we're now wanting to start to count our CPU cycles. So we can put the ticks command immediately before our for next loop. Ticks command takes only one parameter, and that is the name of the variable, which will be a quad, into which you want to put the count. And at the end of our loop, we're going to use the ticksEnd command, which will stop counting and leave the number of CPU cycles in the duration variable. We'll then print that out to our log to see how long it took. So since the duration variable is a number, I'm using the format $command to turn it into a string so we can display it on our log. So if we run our application now, we will see that our process took 126,000 CPU cycles. So this gives us a baseline. We now know how long it takes to run the addToString function. Therefore we can now set up a new function which is going to use the StringBuilder. And we can compare to see how long it takes to run. So we will create a new function to perform this, and we'll call that addToStringBuilder. The addToStringBuilder function is going to be very similar to the function we've just completed. So in order to show how close this is to the original function, we're going to duplicate the function and we're going to change what we need to in this one. We will change the name of the function. We're not going to be using an str data variable, so we will take that declaration out. The variable we're going to use to put all our data into is going to be a StringBuilder variable. So we will define that and call it stbdata. And defined as iStringBuilderA. There are two forms of the StringBuilder object. One is for ANSI strings and one is for wide or Unicode strings. We're not needing Unicode today, so we're just using StringBuilder A. If you need to use Unicode or wide strings, you need to use StringBuilder W. So the next thing we need to do is we need to make the variable equal to the class StringBuilder A. This defines the variable completely as a string builder. Now, as before, we're using the tix command to work out how long this is going to take to run. And rather than adding to this variable here, the strdata variable, we're going to be adding to the stbdata. This can be quite easily done by stbdata.add, followed by the string that you wish to add to the variable. And when we want to add the cabbage return line feed, we take exactly the same approach, using the add method to add the string onto the existing data. And to get at the string that has been built up at the end of our process, we can replace this line of code with this stbdata.string. If we try running our code now, we will see we get exactly the same information coming out on the screen. We get the 5 lines of 10 numbers. However, if we look at the number of cycles taken for the original approach, it's 122,000 cycles. However, the number of CPU cycles for the second string builder function is only 67,000 cycles. That's a considerable reduction on the time taken to actually process the same data. And this is only by adding 50 strings to a variable. So you can see using the string builder object this way is a very efficient way of appending to a string. If you have considerably more than 50 things to add to a string, the advantage becomes even larger. So how does the string builder object achieve this? When you add a string to a string variable, there's a lot going on in the background. New areas of memory have to be set up and populated with the new data. So PowerBasic and Windows underneath is doing a great deal to achieve the object. When you've declared your string builder object, it sets the capacity to around 1K. So if you're adding less than 1K of data, it doesn't have to resize the string at all. We can see what capacity it's actually predetermined by using the capacity method. The name of the object followed by .capacity will display the capacity. If we run this now, we can see that the capacity it's set up is 1024. If you know for certain that the amount of data you're going to be putting into this object is considerably larger than this, say for example it will always be around 5,000 or 6,000 characters, then you can set the capacity up ahead of the game, and this will give you even more performance. If we set the capacity to be 5,000 characters and run the application now, we'll see that the actual capacity is over 8,000. This is because PowerBasic is overestimating the amount of space that it thinks you will actually need. So if you say you need 5,000, it will set up 8,000. And should you add data which exceeds this value, it will increase the size again. So to prove that the increase in speed that we have observed is not down to the order in which these two functions have run, I'm going to swap them round. So we're now adding to the string builder object first, and then doing the normal addition to a string variable second. If we run this now, we will see that the first run took 67,000 cycles, and the second run took 99,000. So regardless of whether you run it first or second, the string builder object still does it faster. So what we've seen today is using a string builder variable type. So what else can you actually do with the string builder? Let's amend our string builder function to actually return a string builder variable. So in the pb main function, we're going to dimension a new data variable, which is a string builder object. And we're going to populate that variable by the return from our add to string builder function. So rather than returning a long, we're now going to return a string builder object, as so. And at the end of our function, the return is going to be the string builder variable we have been building up. So now that we've got that information coming back, what are we going to do with it? We know that the string coming back is going to contain the numbers between 1 and 50. So we're going to search a number out from that string and we're going to replace it. So we will use the inString command to work out the position of the number 13 within the string. we can then use the insert method to insert the number 99 and a space into that position. And we can then output the string of the StringBuilder object to our log. Let's try running that now. We'll see that the number 99 is now preceding the number 13. So we have quite successfully used the insert method to insert a number into an existing string of our StringBuilder. So let's assume we wanted to remove the number 13. We can use the delete method. We populated the long I variable with the position where 13 was originally at. We've inserted 3 characters before that, so if we add 3 to the value within the I variable and mark it for 3 characters. So we're going to remove from that position for 3 characters. If we run this now, we will see that the number 13 is no longer in our string. It has been replaced by the number 99. So what else can we actually do with this StringBuilder object? So far we've populated a single variable as a StringBuilder object. What we're going to do next is we're going to have an array of StringBuilder objects. And we will create a new function whose job it is to perform this task. We'll call that buildArray. So we're going to build a small array of StringBuilder objects. So we've dimensioned a small array from the elements 1 to 10 as StringBuilder. We're going to create a couple of loop counters to actually allow us to populate this array. The next thing we need to do is to use the equals class command to actually define each of the elements within an array as a StringBuilder A object. Once that is done, we're now ready to populate data within the array. So we're going to use a nested for next loop. For each element in the array, we're going to add 10 random numbers to our StringBuilder array object. Just like adding to any normal element in a normal array, you would have the name of the array and in brackets the element you wish to update. And in this case, we're using .add to add a string to that element. And we're calculating a random number between 1 and 5. And we're multiplying that by the value in long C. This will give us a nice random number to add to our array. So for each element, we're doing 10 adds to the StringBuilder object. After the last iteration, we then have information within our array. Now we have to output it to our log. So we can use another for next loop to perform that function. So I'm going to use a normal string array to take the data from this. This allows us to pass it to our function, which only accepts strings. So we will define this string array at the top of our routine. So if we try running our application now, we'll see we now have 10 rows of 10 random numbers. So the StringBuilder object is very flexible. We can use it as a single variable and append to it very quickly. This allows you to build up things like reports, HTML files, or anything that needs to be built up in memory before sending to a report or a user. We can also define an array and reference that array using the standard array elements. We can also use the other methods and properties inbuilt to StringBuilder to determine the length of the string, inserting new strings, deleting existing, clearing the whole object, or setting the capacity for how big our string is likely to be. All giving you a very fast way of accumulating data within a string. Hopefully you'll find this useful in your applications, but that's it for today. Thank you for watching.